Here is a video on how to write equations of lines. So this is covered in expectation C3 in analytic geometry. Okay, so we write equations of lines in the format y equals mx plus b. It's called slope-intercept form. I'll just write that down. Slope-intercept form. And that it's got the name because it's easy to identify the slope, which we use the letter m to represent, and b is our y-intercept. And you can write the equation of any line in this format. So all you need when you're writing the equation of a line is slope and y-intercept. You need both of those things, and then you can write the equation of any line. Okay, so let's take this pink line, for example. So it's easy to identify the y-intercept because it is on the y-axis, and that is the only point on the y-axis, and it's at 1. So we know that b is equal to 1. That's our y-intercept. Or another way to write the y-intercept would be to write it as 0, 1, because x is 0 there and y is 1. Okay, then we need the slope. So the slope, remember to find the slope, we pick 2 points, and we just determine the rise over the run. Now, right off the bat, I can tell that this slope is going to be negative because it's sloping down to the right. So I know it's going to be a negative slope, and I can tell that the rise is 2 and the run is 1. So I know my slope of this line is equal to negative 2 over 1, which is just equal to negative 2. Okay, so I have my slope, I have my y-intercept. So to write the equation on my line, I just say y equals negative 2x plus 1. So see how all I've done is I filled in the m and the b. That's it. That's all you have to do. The x and the y just represent all the different points on the line. So for example, if I wanted to see if, just test out this point or test out my equation, I know that that point is the point 1, negative 1. If I wanted to write that coordinate, it's at 1, negative 1. So let's sub that into our equation to just see what happens. So I'm just going to check. Okay, so y is equal to negative 1, and x is equal to 1. So all I've done is I've substituted x and y into my equation. I'm just doing it to check. And I'll just do the math on each side. So negative 2 times 1 would be negative 2. So negative 1 equals negative 2 plus 1 is negative 1. So you can see here that the left side is equal to the right side. That's good. That's a good thing. That means our equation is true. We did it right. It also means this point is actually on our pink line. Also good. So you can test out to see if points are on your line. You can test out to see if your equation works by subbing in x and y values. But this is the actual equation of the line. It can get more complicated. So write the equation of a line with a slope of 5 and a y-intercept of negative 3. Okay, it's not getting that complicated yet because that's easy. We just use our format y equals mx plus b, and we sub in the slope and y-intercept. So if we have a slope of 5 and we have a y-intercept of negative 3, then our equation would look like y equals 5x minus 3. Now, I didn't write the plus sign because I know that a plus followed by a negative sign is going to translate to a negative. So you don't need to write this double sign here because you know it's just going to be a negative. Okay. Now it's going to get more complicated. Write the equation of a line that contains the points 2, negative 5, and 4, 9. Okay, realistically, we're not graphing this every time. But for now, I'm just going to show you what this looks like. So I've got a point at 2, negative 5. 1, 2, 3, 4, 5. So here. Then I have a point at 4, 9. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've got a line that's formed in between these points. My line's a little bit off. Okay. So I've got this. So this is the line that I'm trying to make an equation of. I don't need to sketch it though, because I know in order to write the equation, I first need the slope and then I need the y-intercept. And I already know from the last lesson we did, I know how to find the slope between 2 points. I just use rise over run. Or y2 minus y1, I subtract my y values, over x2 minus x1. I subtract my x values. So let's do that. So 9 minus negative 5. 9 minus negative 5 over 4 minus 2. So I'm just subtracting my x values and subtracting my y values. It's the same thing as just finding rise over run. So I know these two negatives end up making a positive. So 9 minus negative 5 is the same as 9 plus 5, which is 14. Over 4 take away 2 is 2. So now I can see that my slope is actually 7. We could have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 14 over 2. Checks out. Now to find my y-intercept. So this is where, I'm just going to switch colors. I've got to use my equation to help me. Y equals mx plus b. Now I know my slope, so why don't I put that in? I don't know b. That's going to be my unknown. So I'm going to need to fill in x and y in order to find b. So I can fill in x and y with either of these 2 points. I'm going to choose this point for no particular reason. Doesn't matter. Okay, so 9 is my y value and 4 is my x value. I'm just picking a point on my line. I picked this point. And I'm just doing it so I know what my y-intercept is. It's going to be some super negative number though, eh? Okay, so 9 equals 7 times 4 is 28 plus b. Now I'm going to get rid of my 28, so I'm going to subtract 28 from both sides. So I get 9 minus 28 equals b. And what is 9 take away 28? Negative 19. Yeah, I think. Okay, so now that I know my slope and my y-intercept, I can write the final equation of the line. Y equals 7x minus 19. So I just subbed in my slope and my y-intercept to get the actual final equation of the line. It's not too bad. So whatever information you're given, you just always need to find the slope and the y-intercept, however you can. I mean, a graph's not the worst way, but when the numbers get big, it's not super efficient.